In this chapter, we're going to talk about exception handling. And exception handling allows us to keep our programs from crashing back to the operating system. In other words, it allows us to neatly handle errors in our programs, also called exceptions, so that our programs don't crash. And to begin the chapter, I want to show you an example of why exception handling is necessary. So let's look at a very simple program. We're going to create a variable called numerator, set it to 12. Then we're going to create another variable, denominator, set it to 0. And then we're going to write out the value of dividing numerator by denominator. And let's watch what happens when we build and run this program. Well, as you can see, the program crashed and took me back to the operating system. So all I can do here is close the program. The reason for that is because dividing by 0 is a fatal error, and it will crash your program. And the way we can keep that by happening is by handling exceptions, usually by something called try and catch. And by doing that, we will keep problems like this from crashing programs. Let me show you a very simple example of how to use exception handling, and then we'll develop it further in the coming lessons. First thing I'm going to do is I'm going to come up to the global area, and I'm going to create a constant, divide by 0, and we're just going to set it to a value. It really doesn't matter what the value is. Now, to keep divide by 0 errors from occurring, we need to put our code that we're going to test inside what's called a try statement. I'm going to erase the code and put it back in. So let me go ahead and bracket try. Inside the try, we put code that we believe can lead to an error. So we'll put our code back in. And then here's where we can test for our exception before it happens. And what we're saying is that if the denominator is 0, then we want to throw a divide by 0 exception. Else, cout numerator divided by denominator. And then below our try, let me scroll the screen up a little bit right here, we add our catch. Catch can take an argument. So here we say if e is equal to the constant divide by 0, then cout can't divide by 0. Now, it's really not good practice to write errors to the standard output. Normally you write them to cerr, C-E-R-R. But for this demonstration only, I'm going to simply put it there instead, which is a little bit easier. In the next lesson, in the coming lessons, I'll show you more thoroughly how to catch exceptions and what to do with them. So now let's run this program. And so as you see, rather than crashing the program by testing the denominator, we throw the exception divide by 0. The exception is caught and handled by our catch statement, which returns can't divide by 0. So that's an overview of how exception handling works. Let's move on to the next lesson, where I'm going to show you a more proper way to throw exceptions by creating an exception class and then using that as the means of throwing exceptions.